Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're in Unit 2, Lessons 4 and 5, which is about multiplying polynomials. And we talked last time about what a polynomial is, how we can add and subtract polynomials, and with that we were combining like terms. Today we're going to look at multiplying polynomials. And so I wanted to start by looking at what's called the product property of exponents. And basically what that says, and we have a real general expression here to show that. If I have two terms here, x to the m, and I'm multiplying it by x to the n. So both have a base of x. Exponent for one is m. The exponent for the second one is n. If they have the same base, as we see here, of x, then when I'm multiplying those, we keep that base of x and we add those exponents together. So let's look at what that looks like in an example here. So if I have 3x squared and I multiply it by 4x, well, what the product property of exponents tells me is that we have the same base of x here. This one has an exponent of 2. This one doesn't show an exponent. It's understood that that has an exponent of 1. So it's x to the second times x to the first. I keep that base of x. I add those exponents. So 2 plus 1 is 3. So that becomes x to the third. And then if I have coefficients, as we do in this case, I just multiply those coefficients together. So 3 times 4 is 12. And so the product of those two terms is 12x to the third. My second example here, I have 3xy, and I'm multiplying by negative 7x to the third. So I'm just going to rewrite this real quick. We don't usually put those exponent numbers in there if it's to the first, but I'm going to show them just to help us visualize that. And then here we have the negative 7x to the third. When I multiply these together, I have a base of x in this one and x in this one. So when I multiply those together, x to the first times x to the third becomes x to the fourth. We add those exponents together. I don't have another y term, another base of y, so it's going to stay y to the first. And then we multiply those coefficients. So 3 times negative 7 is negative 21. And so my simplified form or product of those would be negative 21 x to the fourth y. All right, and then the second thing we want to talk about here is the distributive property. And I have an example here again. If I have x and it's being multiplied by another term here, y plus z. So we have a binomial in here. Remember, we talked about this is two terms inside of this one. So y plus z, we're multiplying it by x. What the distributive property says is that to do that, I need to multiply this x by each term that's inside of the parentheses. So that x is going to be multiplied by y. It's also going to be multiplied by the z. And so you'll see here, there's our x times the y. Here's our x times the z. We do those multiplications. Order of operations, multiplication comes before addition. So x times y is xy. X times z is xz. And so using the distributive property, we can rewrite that x times y plus z as xy plus xz. So let's do that in a few examples here. So I have negative 7xy that I want to multiply by this 4x minus 5y. So we are going to distribute that negative 7xy to each of those terms. So negative 7, and I'm just going to show this here in a second step. just so you can see exactly what's happening. So we're taking that negative 7xy times the 4x, and then we're also taking the negative 7xy times the 5y. And so when we do that, negative 7xy times 4x, negative 7 times 4 is negative 28. Xy times x, well, remember that's x to the first in both of those cases. We keep that x base, we add those exponents, 1 plus 1 is 2, so that becomes x squared, and then we still have that y. And then in our second term here, negative 7xy times 5y, well, negative 7 times 5 is negative 35. And then xy times y, we just have the 1x there. Y to the first times y to the first is y squared. And so this becomes negative 28x squared y minus negative 35 xy squared. And if you remember, subtracting a negative is the same as adding a positive. So I'm going to go ahead and rewrite it as negative 28x squared y plus 35xy squared. We would look to see if we can combine any like terms. We don't have like terms here because this is x squared y, this is xy squared, and so that would be our simplified form using the distributive property. All right, one more example here. Here we have two binomials being multiplied together. We're going to, again, use that distributive property. What's going to happen here is I'm going to have the x multiplied by each term in that second one, and then I also have to multiply the 5 by each of those. So just writing this out, I've got x times 3x, x times negative 2. Sorry. Let me fix that real quick here. Went a little too far. There we go. So then that's minus the x times 2 and plus 5 times 3x. And I'm running out of room here. My last one is minus 5 times 2. All right, so x times 3x, that would be 3x squared. X times 2 is 2x. 5 times 3x would be 15x. And then 5 times 2 is 10. All right, this time we do have like terms. We have a negative 2x in the middle and a positive 15x here. So if I add those together, negative 2 and positive 15 is positive 13x, and then minus 10. So that's how we would use the distributive property to multiply two binomials together. All right, and that's all I've got for you today on multiplying polynomials. Appreciate you taking the time to watch. As always, if you have questions, please let me know. Thanks. Have a great day.